Hey everyone, and welcome. Let's talk about something that's totally invisible, works in complete silence, hundreds of miles over our heads, and yet you've probably used it like a dozen times already today. We're going to dive into the amazing world of space missions. Seriously, have you ever stopped to think about it? You pull out your phone, make a call, send a text. How does that signal get from your hand to someone, say, on the other side of the planet in a split second? It feels like straight up magic, but nope, it's pure science. And it's not just your phone, right? How about that live soccer match you're watching from halfway across the world? Or the weather report that tells you, hey, you're going to need an umbrella this afternoon. Where does all this real-time info come from? Well, the answer isn't on the ground, and it's not in the clouds. It is way, way higher up. That's right, the invisible network that's powering our modern life, it's not just about cell towers and underground cables anymore. A massive piece of that puzzle is orbiting silently right above us, turning our big planet into a tiny, connected village. And here it is. The big answer to all those questions is artificial satellites. For more than 60 years now, we've been launching these incredible machines into space, weaving this amazing, invisible web all around the Earth that connects every single one of us.
Okay, so what in the world are these things really, these high-flying pieces of tech? And what makes them different from, the moon? Let's get into it.
It's actually pretty simple. Over on the left, you've got a natural satellite. The moon is the perfect example. It's just a big rock that naturally orbits a planet. But on the right, that's our creation. An artificial satellite is a man-made machine that we intentionally put into a very specific fixed orbit. The very first one ever was Sputnik, launched by the Soviet Union way back in 1957. That little guy basically kicked off the entire space age. And not all satellites are doing the same job. They're actually super specialized. Think of them as tools. Some are weather satellites, there are eyes in the sky watching storms form. Others are communication satellites, bouncing our calls and internet data across oceans. Then you've got navigational satellites. That's the whole GPS system right there, telling you exactly where to turn. And of course, Earth observation satellites, which keep an eye on everything from our forests to our oceans. Each one has a very specific job to do. So this leads to the next big question, right? If these satellites are so important, how on Earth do we get them up there, hundreds or even thousands of kilometers into space? And maybe even more important, once they're up there, what stops them from just falling right back down to Earth? It all comes down to some pretty cool physics and some seriously incredible engineering. And it all starts with a law you probably remember from science class, Newton's third law. For every action, there is an equal and opposite reaction. You've seen this before. Think about letting go of a balloon you've just blown up. The air shoots out the back, that's the action, and the balloon goes flying forward. That's the reaction. Well, a giant rocket works on the exact same principle, just on a much, much bigger scale. But you can't just light one big firework to get to space. Earth's gravity is super strong. So we use these really clever multi-stage rockets. Here's how it works. The first stage, which is huge and full of fuel, ignites and does the heavy lifting to get off the ground. But once its fuel is used up, it just drops off. This makes the whole rocket way lighter. Then, the smaller second stage engine kicks in, pushing this new, lighter vehicle even faster and higher. By shedding weight as it goes, the rocket can finally get our satellite to the perfect speed and height. And then it just lets it go into orbit. And orbit isn't just one place. You can think of it like different highway lanes in space. You've got low Earth orbit, or LEO. That's like the busy city streets, close to Earth. It's where the International Space Station and the Hubble telescope hang out. A bit further out is medium Earth orbit, MEO. That's where you'll find the GPS satellites cruising along. And then way, way out there is high Earth orbit, HEO. That's where satellites can perfectly match the Earth's rotation, making them look like they're just hanging in one spot. It's perfect for broadcasting TV signals or keeping a constant eye on the weather. But space missions aren't all just about practical stuff for us here on Earth. Some of them are driven by something way older, something deep inside us, that simple, powerful desire to explore. So let's talk about our journeys to our closest neighbors, the Moon and Mars. Our journey to the Moon has been this incredible global effort spanning generations. It really started with robotic missions, like the Soviet Union's Luna 2 back in '59. Just 10 years later, of course, Neil Armstrong took that giant leap for mankind. And the exploration hasn't stopped. In 2008, India's Chandrayaan-1 mission made a discovery that was absolutely monumental.
And that discovery was finding proof of water molecules on the moon's surface. Now, this wasn't just some small detail. This was a total game changer. The idea of finding water on the moon could change everything for future space travel, and it was India's mission that made that critical find. So after the moon, the next logical stop is Mars. But it's so much harder to get to. A lot of missions have failed trying, which makes what India's ISRO did in 2014 even more amazing. With the Mangalyaan mission, they successfully put a spacecraft into orbit around Mars on their very first try. It was an incredible achievement that gave us priceless data about the red planet. Now, behind all this incredible technology, all these landmark missions, there are always people. It's that human spirit of curiosity and sheer determination that really powers these journeys. So let's just take a moment and recognize a few of these incredible pioneers of Indian origin. People like Rakesh Sharma, the very first Indian citizen to go to space. Or Kalpana Chawla, who flew on the Space Shuttle Columbia and spent hundreds of hours in orbit. And Sunita Williams, who set records for her time in space. These are some of the heroes who have carried our dreams and ambitions into the stars. But with all of this success, all these satellites, all these rocket parts, all these missions, we've accidentally created a brand new problem. The space right above our planet has started to get, well, a little bit crowded. We're talking about space debris, or as a lot of people call it, space junk. This is stuff like old satellites that don't work anymore, pieces of rockets that were jettisoned after launch, even tiny fragments from collisions. Basically, anything man-made that's just floating around up there with no purpose, that's debris. And the scale of this problem, it's just mind-boggling. Just a few years ago, it was estimated that there were around 20 million, that's 2 crore pieces of debris bigger than a centimeter orbiting Earth. Think about that, 20 million tiny bullets whipping around the planet at incredible speeds. And here's why that's so terrifying. Even a tiny fleck of paint, when it's traveling at orbital speeds, can hit a working satellite or a spacecraft with devastating force. All this clutter isn't just a mess. It's a direct threat to the very technology we depend on every day, and it makes every future launch more and more dangerous.
So that kind of leaves us with a final, really important question. We lean on space for so much of our modern life, and our hunger to explore is never going to go away. But as we keep pushing farther out into the cosmos, we have to figure this out. How do we solve the massive traffic jam we're creating right here in our own cosmic backyard? How do we make sure that the path to the stars stays open for all the generations to come?